Hello, guys. Welcome to Ramta Solutions. Welcome to your grade 11 mathematics Euclidean geometry. Today we are proving the Tan-chord theorem. Okay, today we are proving the Tan-chord theorem. So this theorem says it says the angle between a tangent to a circle. You can see in this case our tangent is AD to a circle, and a chord drawn at the point of contact is equal to the angle which the chord subtends in the alternate segment. So the chord drawn at the point of contact, this time we will take it to be AB, as you can see. All right, we will take it to be AB. They say that angle between the tangent and a chord, which is this angle here, will be equal to the angle which the chord subtends in the alternate segment, which is this angle here. Okay, so whenever we use this theorem, you must always give the reason Tan-chord theorem. Okay, so we are given information, as you can see on the circle, that we have a center with circle O and a tangent AD that is touching the circle at point O. All right, and then we have chord, let's say we will take chord AB, okay, that is subtending angle C. Can you see that? Chord AB subtending angle C. Okay, this makes it a triangle. Cool. So our duty is to prove that angle DAB, this angle here, is equal to angle BCA, this angle here. Okay, I will copy this shape here and paste it. Let's see, pasting it as is. Okay, so I think it's better this way. I think it's better. Okay, yeah, perfect. So what we're going to do now in our proof, by the way, this is our proof. Okay, this is our proof. So in our proof, we're going to begin with a construction. Okay, we're going to begin with a construction. In that construction, we are going to draw AO extending to, let me see, A, B, C, D, extending to E on the circumference. Okay, extending to E on the circumference. Okay, extending to E on the circumference. Perhaps let me show that. So we say we have something like this. All right, that's it, buddy. Now we're calling it point E, isn't it? We're calling it point E. It is extending to the circumference, as you can see, meaning E lies on the circumference. Okay, so by the way, and then join another point, join EC. So to join EC will be this here. Okay, then join EC. So if you like, guys, you can include this information. I'm going to say here we have 1, 2, 1, 2. All right. So you can also include this information, the 1 and the 2s, the 1s and the 2s, you can also include them in your construction. Okay. You can also include them in your construction. Okay. For example, in my construction, I will basically be saying angle BAD. Okay, angle BAD is equal to A1, and then angle BAE is equal to A2, and then let me see, angle ACB is equal to C1, and then angle BCE is equal to C2. You can also say something like that. Okay, but good thing about this is that they will give you this information, this shape here, without the red edits that I have made here. Okay, so you can do the same thing that I did here. Now let's then get into our work. Remember, we are proving that angle DAB, right? We are proving that angle DAB is equal to angle BCA, right? Angle DAB is equal to angle BCA. Okay, let's go now. Right, let's see. So when we proceed, you will agree with me that angle C, okay, let me not call it angle C, but let me call it angle ECA. Is it better? Let me call it angle ECA or angle ACE, whichever you like, will be equal to 90 degrees. And what's the reason? Angle at the center is twice angle at the circumference. Otherwise, you can say angle in a semicircle. Right? You can say it is angle in a semicircle. Right? You can say it is angle in a semicircle. Right? In the same way, you can say that, angle EAD, right? Angle EAD is equal to 90 degrees. Let's show you. Angle EAD is this one here. It is equal to 90 degrees. Why? It is passing through the center, and it is basically the intersection of the diameter and the tangent. So the reason is tangent is perpendicular to diameter. Let me just write this diameter in full. Okay, tangent is perpendicular to diameter. All right, to diameter. Now, I do see here, I can say angle C2 is equal to angle A2. I have seen something like that. Angle C2, okay, angle C2 is equal to angle A2. Why? These are angles on same segment, right? These are angles on same segment. Remember, ABEC is a cyclic quadrilateral, right? So we are correct to say it is a cyclic quadrilateral. So as you can see, they are like this, or they are like this, right? So we can say angle C2 is equal to angle A2, right? Good. Now we can say, if you recall, we said angle ECA, all right? Angle ECA is 90 degrees, right? Oh, angle ECA is this one here, is 90 degrees. We did have some information on C2, so we can say something about C1. If this angle here is 90 degrees, and we said this one here is equal to this one here, let's proceed. So we can therefore say angle C1 is equal to 90 degrees minus angle C2, isn't it? Because what did we say? Angle ECA is equal to 90 degrees, right? But angle C2 is equal to angle A2. Therefore, angle C1 must be equal to 90 degrees minus angle A2. Okay? Cool. Now, angle EAD, tangent perpendicular to diameter, is 90 degrees. So, we did say something about A2. Maybe let's get information about A1. What we know is that A1 plus A2 will be 90 degrees. Therefore, we can say angle A1 is equal to 90 degrees minus angle A2. Oh, C1. Look at this angle. C1 is equal to 90 degrees minus A2. Angle A1 is equal to 90 degrees minus A2. Okay. Therefore, we can say angle A1, right? We can therefore say angle A1 must be equal to angle C1. Whew. Let's go check it out. Angle A1. What did we say angle A1 was? As you can see, angle A1 is here. It is equal to angle, which one are we proving? Angle DAB. Can you see it? So we call it angle DAB. So angle DAB is equal to angle C1. What is angle C1? Oh, angle C1 is this one here. What did we call it? We called it angle BCA, isn't it? We're saying BCA, right? So angle C1 is this one here. Indeed, it is BCA, right? It is equal to angle BCA. With that being said, you have proved your Tan-chord theorem. Remember what it says. The Tan-chord theorem says the angle between a tangent to a chord, which is this one here, right? Between a tangent to a chord, between a tangent to a circle and a chord, at that point of contact is equal to the angle which the chord subtends. This one here. Happy? And this is your Tan-chord theorem. Right. Remember, guys, if you would like to get in touch with us, visit our website www.ramtasolutions.co.za. And if you are watching on YouTube, in the description of this video, you will get the links. You will get the links to the different social media platforms that you have. Okay. Now, with that being said, we can say ours ends here. And remember to subscribe, like, and share the video with friends. And of course, if you're watching on TikTok, remember to do the same. All right. So, bye bye.